Welcome to AS Structures. In this video, I'll guide you through the steps to design a beam using the program. First, open the AS Structures program and log in. Once logged in, navigate to the main menu and select Beam Design to get started. Next, go to the 𝗘𝗘𝗔𝗕𝗦 model for frame analysis. This is where the program performs the necessary structural calculations for the beams. Now, select the beams you want to design. Go to Select, Properties, Frame section, then choose the beam you want to design. You can also manually select beams by clicking on them directly in the model. Then navigate to Display and select Show Tables. In the table display, choose Analysis Result, Element Output, Frame Output, then Element Forces on Beams. Make sure to check the Selected Only box to design only the pre-selected beams. Deselect all load patterns and load cases, but ensure that all load combinations are selected. Once done, click OK. This ensures that all relevant load combinations are considered for the beam design process. Next, click on the upper left box here and press Ctrl+C to copy the data. Next, go back to the AS Structures program. Select the Insert Reaction tab and click Clear to remove any previous data. Then, select Paste to inject the newly copied beam forces from the 𝗘𝗘𝗔𝗠 model. Now, let's move on to the design process. The program will automatically determine whether the beam requires a singly or doubly reinforced analysis. Next, input the adequate number of main bars based on your design requirements. Then, input the spacing of the stirrups. As you can see, as you modify these parameters, the drawing will also update to reflect the changes. One of the features of this program is that it allows you to rotate the drawing model, giving you a better view and control over the design from different angles. This makes it easier to visualize and adjust your beam design to meet the required specifications. Another feature of the program is that it allows you to see a print preview. But first, click the Insert Project Detail tab. This tab lets you input important project information, such as the project location, owner, and other relevant details. It also allows you to enter the designer details such as the name, license number, and contact information of the structural designer. Once you've entered the required information, click the Preview button to see the report preview. All the information you've input will be reflected in the report analysis. You can also export the design report to PDF by clicking the Export tab and then selecting Export. This will create a PDF version of your design report. You can then save, print, or share the file for documentation purposes. The exported PDF can also be used for official submissions or archiving project details. You can also export the critical load data with graphical outputs for better visualization. First, return to your 𝗘𝗘𝗔𝗠 model and switch to a 3D view. Click on the member force diagram and in the component selection, choose axial force, then hit Apply. Use Windows +Shift+S to take a screenshot of the model. Back in the program, open the Insert Diagram tab and paste the screenshot into the axial load section. Repeat this process for the shear 2-2 component by selecting it in 𝗘𝗘𝗔𝗠, clicking Apply, and taking a screenshot. Return to the program and paste it into the beam shear section. Next, move to torsion in the 𝗘𝗘𝗔𝗠 model. Apply the setting and capture a screenshot. Head back to the program and paste it into the beam torsion portion. Finally, select moment 3-3 on the model. Apply it and take a final screenshot. Complete the process by pasting this image into the beam moment section in the program. This sequence ensures all critical loads are captured and displayed effectively for your design report. Now select the Export PDF tab on the program and click Export Applied Reactions to PDF. This action will compile all the applied reaction data, along with any visual diagrams, into a comprehensive PDF report. This report can be saved, printed, or shared, providing clear documentation of your design's critical reaction details. Lastly, you can add multiple beams to your project, allowing you to manage and design various beam elements within one session. This capability is particularly useful for handling complex structures efficiently. You can also navigate through each beam to review and modify its design parameters as needed. This makes it easy to access and adjust specific beam details without restarting the design process, saving time and effort. Thank you for watching this tutorial on using AS structures for beam design.